All right, on this video, we are going to talk about like terms, okay? So if you remember, a term is something like you see here. A term could be 3x squared. It could be just a number by itself, like 6, or it could be a 4y, okay? So it can be a number by itself. It can be a number attached to a variable with an exponent, like 3x squared, or it could be a number attached just to a variable with no exponent, like 4y. Okay, so it can be a variable, a number, or a combination of both. So we have 3 different terms here, okay, but when you are starting to learn algebra, you start learning that you can combine what are called like terms. So like terms, I'll just write it up here in my bad handwriting. Like terms is the same as terms that are alike. So that's the way I think of them. Okay, so you can combine terms that are alike. All right, when we talk about combining, okay, when we're talking about combining like terms, we're talking about adding and subtracting. So you can add and subtract terms that are alike, okay? And later on, you can learn more about multiplying and dividing. You can actually multiply and divide terms that are not alike. So, but that's for another day. So combining like terms, that's when you're adding or subtracting terms that are alike. So let's take a look at some examples. Okay, so on number 1 here, we have 4x plus 6x, okay? So we've got to figure out, okay, are these like terms? And the answer is yes. On this one, yes, these are like terms. And so the reason they are is because both terms have the same variable. So if they have the same variable, I'll write it up here, same variable, and like we talked about combining them, well, we're adding, right? So if we're adding, that means we can combine them, and we can combine them because they have the same variable. Then that tells us those are all the signs to say, okay, we can combine these like terms. And if we did, it would come out over here as 10x. Okay, so there's basically, you can imagine if you had 4 x's, and then you added 6 more x's to it, you would have 10 x's, so 10x. That's how I think of it, okay? All right, so they have the same variable. Now, some people get this mixed up. Some of my students, they say, well, what about this 6 and this 4, the what we call the coefficients? Okay, so the numbers that are attached to the variables, those are different. 4 and 6 are not the same. Those are not alike, right? They're not the same number. But that's okay. With like terms, your coefficients can be different, just like 4 and 6 are different. But as long as the variable they are attached to is the same, so in this case, x, then they are still like terms, and you can combine them like we did. Okay, so that's important. So even the coefficients, they don't have to be the same for there to be like terms, okay? All right, let's look at example number 2. This is an example where they are not like terms, 4x plus 6y. And the reason is the variables, okay? The variables, now both terms have a variable, but the variables have to be the same. It has to be the same letter, okay? So this is going to, these are not like terms. And our reason over here is variables aren't the same. Okay, so there's an example of we cannot combine these terms. They are not like terms. We have to leave them like the expression is right here. Okay, all right, so let's keep going. So some more complicated examples. Okay, so number 3, we've got 7x squared minus 3x squared plus 2x minus 1. So we have 3 different terms here that have the variable x. But here's another part of understanding like terms. Okay, this 2x, okay, technically does not have the same exponent as the other x terms. So 7x squared and 3x squared, they both have that exponent of 2. So the x has an exponent of 2, but this 2x, right, has an exponent technically of 1 right there, x to the first power. They don't write it there because it doesn't make a difference. X to the first power is just x. But technically, that's x to the first power, and these, therefore, are not like terms. So 2x is not like terms with the 3x squared and the 7x squared because 2x has an exponent that is different. Okay, so a different exponent with the variable. So if the variable has a different exponent than the other terms, they are not like terms and you cannot combine them. Okay, so now 7x squared and 3x squared, they both have the same exponent of 2 over x. Okay, and because of that, they are considered like terms because they have the same variable x and that variable has the same exponent as the other term as well. Okay, so we can combine 7x squared and minus 3x squared. So if we did that subtraction, that's like saying, okay, I have 7x squareds and I have 3x squareds. What if I do I have 7x squareds, but I take away 3 of them? So that would be 7 minus 3 is 4. So that would leave me 4x squareds left. So I would write 4x squared after combining those two like terms. But now I still have to write out plus the 2x that's still there, and minus 1 is still there as well. And we can't forget about that. So that's as simple as I can get that expression, okay? And I combined the like terms that I found, but there were a couple like 2x and 1. Those were not like terms with any of the other terms in the expression. So this would be my final simplified expression, okay? Now, we didn't talk about the minus 1 at the end here. The minus 1, so if you're just looking at it as a term, it's just 1, right? Because we're not counting the operation symbol. But just 1 by itself, is that a term in itself? Yes, it is, because a number by itself is a term. Okay, we call those constants. Okay, so that's a constant, a number by itself, but it doesn't have a variable. It doesn't have an x variable, and therefore it can't be a like term with the other terms in that expression, so we leave that alone. Okay? All right, let's look at example number 4. Example number 4, 8x squared minus 4y plus 2x plus y plus x squared. All right, so we're trying to figure out which terms have the same variable with the same exponents. So technically we have 3 terms here that have the x variable in it. Okay? Well, only 2 of them, 8x squared and x squared, only those 2 are like terms, not 2x. Okay? Because 2x x only has an exponent of 1 there, and therefore its exponents don't match the other 2 exponents. Okay? So, if we were to combine those terms, 8x squared plus x squared. So you might say, well, can we combine them? They're on different sides they're on totally different sides of the expression. So wouldn't that mean we can't combine them? And the answer is no, you can't. You actually can combine those even if they're on different sides of the expression. Okay? Because you can basically just skip over the other terms that are after 8x squared. Okay, you can skip over those for right now, and because they're not like terms with 8x squared, and you can do 8x squared plus x squared. And if you did that, technically x squared is like technically a 1x squared, right? So 8 plus 1 is 9, that's 9x squared if I combined those 2 terms. Okay? And so Let's see, from there, so now we got to check, okay, I combined the 8x squared and the 1x squared. Can I combine any other terms in this expression? So I've got a negative 4y here, and I've got a y over here. And that's technically a plus 1y, right? Okay, so negative 4y plus 1y, I can combine those because those are like terms. They both have the variable y, and their exponents, technically the y's both have an exponent of 1, so those are matching too. Okay, so negative 4y plus 1y is a negative 3y. So I write that down after 9x squared. All right, and the last term I haven't touched yet is this 2x. Okay, but I'm looking everywhere else in my expression. There's no other term that has x just with an exponent of 1. Okay, so that means there are no other like terms to combine 2x with, so I'm going to leave it as plus 2x in my next step. So I leave that alone. There is my simplified expression after combining like terms. Okay? Okay, so those are examples on combining like terms. I will have at least one, maybe two more videos that go more into depth on examples on identifying like terms. So if you would like to watch those, don't forget to check my channel and subscribe as well. Thank you so much.